So in this Matlab tutorial, we're going to talk about some basic linear algebra in Matlab. The first thing I want to talk about is how to solve linear equations. So in general, these are in the form of ax plus b, where a is a matrix, x is a vector of the variables you want to solve for, and b is a vector of constants. So if you remember from linear algebra, a system of linear equations is when you have more than one variable and the same number of linear equations. So in this example I'm looking at right here, the variables are x, y, and z, and because there are three of them, I have three different equations. So one way of writing the problem is just writing the equations out explicitly like this, or you can write it out in matrix form. So in this example, A would be 3, 2, minus 1, two minus 2, 4, minus 1, half, minus 1. Okay, so that's A. B is 1 minus 2 minus 2. Okay, so when you're working with equations like this, you might be tempted to do just simple algebra. So you could say x is equal to the inverse of A times B, because mathematically that works. So I can do that. Oh, and right, I have to make B a column matrix. So A times B. Sorry, I used the wrong B. Okay, so inverse A times B. So I get 1 minus 2 minus 2, which is the answer given on Wikipedia. So sometimes when you try to do something like this, Matlab will give you a warning. This is a very inefficient way of calculating this answer. This Matlab already contains algorithms to solve this problem. So if you remember from before, when we were talking about operations, we were talking about the division operations and how there's a / division and a / division. So this is the use case where you'd want to use the / division. And if you kind of think about it, if these were scalars, x would be b divided by a. But since they're matrices, we write the answer like this. So a / b. So it's kind of like a is underneath the b, right? And so if I do that, you can see that I get the same answer as when I did inverse of a times b. So that's how you solve systems of linear equations in Matlab. So now we're going to talk about some other linear algebra concepts that you can do in Matlab. One of them is taking the determinant of a matrix. And so that is just a simple function called det. Okay. So remember A was 3, 2, minus 1, 2, minus 2, 4, minus 1, half, minus 1 from the last example. We can also compute the eigenvalues of a matrix. So Eig A, Eig. And now you know when we compute eigenvalues, we usually want the corresponding eigenvectors. Now, so one interesting thing about Matlab that differs from other languages is that what is returned by the function is not set in stone, it's dynamic. So if we look at the documentation for the Eig function, we see that if there's one output parameter, it returns this little e. And the Matlab documentation says e contains the eigenvalues of the matrix A. But say I want the eigenvectors also. And so you can see these different function signatures. So if I assign the return values of Eig to two different variables, I can get back, let's read here, a diagonal matrix D of eigenvalues in a matrix V whose columns are the corresponding right eigenvectors. So the eigenvalues are going to be returned in a matrix called D, and the eigenvectors are going to be the columns of the matrix V. So let's try that. Equals Eig A. Right, so we get a diagonal matrix D, which has the same eigenvalues as before, and then the eigenvectors are all in V. And so let's just confirm that the definition of eigenvalues and eigenvectors holds. So A times V should equal V times D. Right, and so here's another thing interesting about Matlab is that if we want to check if two things are equal, we can generally use the equals equals as we do in regular programming. So 1 equals equals 1 is 1, which means true. 1 equals equals 0 is false. So if we do A star V equals equals V star D, we get false, which is surprising because they should be equal given that that's the definition of eigenvalues and eigenvectors. But we have to remember that there's always in programming some round off error. So if we subtract A times V minus V times D, we should get back a very small number. Right? And so we do that, we see 1 times 10 to the minus 14, which is indeed very small. So for all intents and purposes, they are still equal, even though equals equals returns false. Now, so that brings us to the next thing I want to talk about, which is, so we have this matrix A times V minus V times D, which kind of represents all the differences in those two matrices. And so we want to ensure that all the values are small. Now there are 9 different values in this matrix, so it's kind of hard to tell how big or small it is collectively. So one thing we want to do sometimes when we have vectors or matrices is we want to calculate the distance from the origin. And so we can do that with vectors. With matrices, we call that the norm. And so typically, all the elements, so in a Euclidean space, for example, it's all the elements squared, added together, and then you take the square root. So in Matlab, there's a function called norm that does this. So let's just see what that gives us. So it gives us one very small number, so 5 times 10 to the minus 15, which we again can use to confirm that it's very close to 0. So A times V is very close to equal to V times D. And if you remember from your math courses, there are different kinds of norms. So I talked about the Euclidean norm, which is norm 2. We can actually do a p-norm, which is, so instead of taking the square and summing them all together and taking the square root, we do every element to the power of p, sum them all together, and take the pth root. So, and that's just the second argument of norm. So if I put a 2 there, I should get the same answer because p equals 2 by default. So you can't use p equals 3. You can only use p equals 1, 2, infinity, or fro. And so 1 would be the Manhattan distance.